Let's start the lecture number 8, process design and chemical management, which focuses on save energy, save money, right? Reduce nutrient discharge, right? That's our focus. We talked a little bit about energy. We didn't go to the part of money, right? And also nutrient reduction, right? What it says, what is this process and chemical management? When we are treating a large quantity of wastewater everywhere, think about the whole nation. Wastewater is produced 24 hours, 365 days. Right? So economics is also very important. Correct. Then our treatment cost is also important. Right? And when we talk about the reduction, what we think? We think in the first place, is it possible to reduce the pollution at the source? Right? Once you produce the wastewater, then you find the solution. But is it possible to reduce it at the source itself? See, one small example. Earlier, plastics bags they used to supply everywhere. People just to go bare hand and but before that, if you see our earlier people, they used to go to the with the bag, purchase stuff. You all know it is in our period only because it is not that earlier people used to do in your period only. Then what? People stop taking the bags. Now bags are everywhere. Why you do that in the first place? When the system was already existing, you brought that, made plastic available everywhere, then you create it. That is why man-made pollution. This is means you are first creating the pollution and then you are trying to find the solution. Why? That is what we think first in the reduction at the source. So then what you did? You used a simple technique. You stopped manufacturing. Then people went to higher grade of plastic little. You made it expensive. You made it uh, the car maybe 2 rupees. Rupees doesn't exist, I think. No. So some amount you made. You increase that value, then 50% people stop using. You have to pay money. So if they ask you, do you want a bag? You say no. Why? Because you have to pay. So these are a simple solution. First, it was going well. People were going with the bag and everything. So that is how you have to think reduction at the source. If you give it free, it is usual tendency. Then people want everything, whether it is needed or not needed. But if you have to pay, then people think whether to really need it or not. So that is what the concept is. Reduction at the source. Nutrient removal is also one of the factor in this. Energy, nutrient removal is important. When you say that there is a problem, there is a pollution, your mind must go to little backside. What is the origin? What is the source? Is it? That is what I try to highlight some of the factors. Is it? So purpose may be different. See, earlier purpose, that is what I mentioned, how people look at it in a different. So in the process, chemical management is the process of handling chemicals in a safe and environmentally responsible way. It important for workplace safety and environmental protection. You use chemical because it is inevitable. When you use a chemical, what you do? You have to optimize. How much is required, that much only you can use. Number one. Whether is it necessary? Is there any alternative? Yes. Where do you use chemicals? You use to reduce pH, increase pH, because you may be needed for that process. All the processes are not same. If it is a biological process, you want to have a proper pH where that can be used, because you are using that in order to make the process efficient. But there is also another process. What we did in the equalization tank, we took a low pH wastewater and we took a high pH wastewater and we neutralized. Is it not smart? But there was an opportunity. If you tell the industrial dischargers, no, you treat your change your pH at that discharge. Why? Because it is a regulation. pH should be between this to this. So he will also treat, he will also treat. You just applied a mind. See, if you work in a team, work with the understanding, you can reduce. See, two treatment you reduced there, and free of cost you created the required pH. You don't want to treat if it is not required at different stages. Who will take that decision? How you will determine? Right? There is no magic. People who are in the authority or people who are operating, they can make this determination to run. When you are using the chemical, you have to spend a lot of money, and when you are bringing chemical, it has to be safe. It is not like that you can just store wherever you want. If any chemicals are to be have stored in the laboratory or in the process plant, it must be safe, because a lot of people will be there. In case of spill, there is an emergency solution you need, documents should be there, people should know, people should have a safety awareness, safety equipments, safety protective equipments for the people who are working in that. If there is in a big tank of lime or acid, if you are want to use a diluted hydrochloric acid to reduce pH, if it is just kept it there, if there is a leakage, people will be walking bare foot. Many people have. They were not using the protective equipment. They may be using a normal shoe. And you can't differentiate whether it is really a chemical or not. It is mixed with water, it is just flowing. So safety is important. All chemical must be stored in a secondary containment. You should always think. Now you can easily think, no? So if it breaks or if there is a leakage, what you can? You can have another container, secondary container. It should be there, then you should make sure. You should not wait until secondary containment is also. So that is, you get some breathing time. Oh, that's why the people working in the safety have to be attentive. When you go to the process plant, you will see, is there any leakage? Is there any, that's why the what you call for the industries in the processing area, you adopt best management practices. You make sure everything is clean, neat, visible. People have an understanding. Right? Operator who are transporting the chemicals from one or other places. They must be aware what it is. They must have a training. Otherwise, they will just like a water if they are taking, it is possible. They don't know because they want to just have an employment and they will be doing how much you are spending money. Why you are not using the protective equipment for them? Where are their PPE? Why you don't ask question? Anybody from Delhi here? Any person is, yeah. You are from Delhi? I am telling you is there is a lot of cleaning going on there in the river. You see, lot of people were working cleaning stuff. Do they have protective equipments? Why? You say it is polluted, you cannot touch that water. There is a, see, these are the things, right? That's what I just want to bring attention. I don't want to comment much on that, but see, you see there. That is also true for the industries. People who are working in the with the chemical, they must be aware why you create a MSDS, why you train them, why you put the safety protocols there. They are important. It must be followed, trained. How much you spend for the training? Are your people are trained? How many crews were there yesterday when we are? Was there any question? You were asking good questions. I like. But how much you spend on the training? That's an important question. How often you give training? People are trained. Do you use protective equipment? Right? So those are the things when you are dealing with the chemicals in a safe and environmentally responsible way. It is important for workplace safety, environmental protection. That is the first step. It's very simple. Do you need a lot of technology for this? No. So principle of chemical management. Management is not only just applied for money, right? It is applied for chemical management also, right? So you have to always have an good and identify the hazards, recognize the chemicals that are hazards, assess the risk, evaluate likelihood of exposure to the hazardous chemicals. If they are exposed, what you will do? If you don't have a training, if because there is a possibility, there may be a leakage. You can't say that it is 100% proof, right? So that is why it is important. The people working in that system must be aware, right? Right. So those things are important. That is what I want to mention about this, because you need an MSDS operating manual. Everything should be visibly displayed, not just in the computer. When you go tomorrow or to the industry, you will first ask, where is MSDS? How you will handle your camp? How other person know? Today is one person who is doing the stuff, and he will go after 8 hours. If a new person is coming, is he aware? Or he has to tell every day. If a new person come in for the work, of course you have to give some training, that is there. But whether really training is there, you can you keep everything in your mind? So there is a leakage, this chemical, oh, these are the things I should do. And those are things must be more visible. Process and chemical management, again, control risk, chemical management practices, maintain inventories, keep track of the chemicals used on site, ensure they all meet the criteria. There is a guidance document, how you have to build. Who will do this in the industry? If you are in charge, is it not your responsibility to do this? That's why you have to be active. You have to make sure that things are done. That's what I said. Responsibility is important. You are there for that position, but are you responsibly delivering? If you deliver these things, how safe it is. You don't need any management, right? So there is a management also in the industry. Management people are there. What's her name? Srishti, right? Yours. Vidya. Management people will do the management of money, but this is also management. So you should also pay attention for that management, right? So that is important. So when you are in the industry, do management stuff, what are other managements are also related. It is not just the money management. We will come to that. Money management is important, but human health, that's a fact. I want that you should understand if anything that happens in some other countries, they have to pay in millions. So, fine. Simple things, simple management it is. Just I told the example of parking. If you put parking in the city, big amount, people won't bring, just like that plastic bag. So that is how you have to do and manage, right? So those are the things, simple things you have to adopt. Maintain inventories, keep track of chemicals, how much you use, how you store, whether it is required or not, how to apply, right? Minimize the contact, use wet methods to reduce dust and particulate and use fumes, food, right? In the coal industry, dust is the biggest problem. We spend a lot of money on the dust control. I wrote a big document how it has to be managed when I was working there. How to manage dust control. Otherwise, what happens? If there is a dust, big driver comes, we cannot see what happens. If there is a dust all over, everywhere, it will nearby houses, people there, children. Huh? If you don't pay attention, so those things are important. Adjust the work schedule to rotate the job assignment, adjust the schedule to avoid overexposure. See, there are certain things people can work more efficiently during that period. Person is working, you ask him to work for 24 hours. There may be some people who may interested to work for money. It doesn't mean that you want to risk his life and others' life also. If he is doing some important job, if for a driver is driving vehicle, if you ask him to drive for 24 hours, what will happen? He is ready to do, but what he will do, right? So simple, it doesn't need any management. So that is why overexpose certain, exposure you have to be for certain hours only. If you expose that for a longer period, it may affect the health. It may affect his health. That is important. Yeah, affect your efficiency bit. That is different. So that is why who will do this? No need to take disadvantage if person is working for 8 hours, work for lesser price. No, that is not. Train employee, that is how much you spend money on training. You bring a person, if he doesn't know, what will happen? So that is a problem, right? Manage waste, collect, separate, recycle, dispose chemical waste safely and responsibly. That is the people who are working in the solid waste, what they will do? Segregation. If you segregate at the source, it is easy to treat that. What we do? Biodegradable, non-biodegradable, recycle, we do. So we have two things there, recyclable and degradable, and garbage, care and recycle. Right? That is important. You cannot mix. We do that. If you put the recyclable stuff in the garbage, it is not acceptable. If you do that, they will give one warning, then they will put a fine. You will be straight. Right? So if you segregate, how easy it is. You don't mix and then you need a people to segregate. So that is why source reduction is important. So process and chemical management need to recognize the common operator error, how to eliminate them, to reduce aviation, to achieve energy and money saving. That's why if it is needed, you do, otherwise don't. That's why you have numbers to play with. Reduce aeration to decrease the nutrient loading discharge to receiving waters. Unnecessarily don't discharge nutrient. There are sources which are non-controllable, non-point sources. If the storm is there is a lot of pollution going on already. Point source which is coming at the industry or from this particular point, you have a control. And if non-controllable, it is such a difficult things to do. But in controllable also, if you are started doing like that, so where it will end. So that is important. So to understand activated sludge process better, first you understand how that process works. Don't do randomly, mechanically. There is a philosophy, process. So that you should understand. You have to train. If that's why frequent training is important. How you train, how you do. It is not necessary that you know everything. Update the stuff. Give a training, right? Give him a time to understand. That's why there is a training period. But training period is usually done for that kind of a training, that much, or the first day only you will start using. That is not acceptable, right? So VOD removal, nitrification, TSS removal, maintaining neutral pH for the activated sludge process. So you should have optimize what under what circumstances it is efficient, correct? Then minimize the quantity of solid produced. First you produce, and then you find a ways to treat it. Then try to reduce at the source itself, right? Optimize the energy use. That is important, energy, because these aerators are on for 24 hours. Even if 5% reduction makes a lot of difference. Denitrification, phosphorus, understand the process. Right? Process performance, successful activated sludge process performance is judged by effluent quality. So you just don't want to measure influent and effluent and make a decision. You want to analyze each unit, each process, each stage to make it more efficient. You have to work from whole to part, not from part to whole. You see what you need, whether these units, accordingly you are designing the units. You want to say in the design, this is the objective, this is the influence, I need an objective goal to achieve this. Then you see the intermediate units are performing, heading up to that level. Otherwise, just don't measure here. You see whether the process is taking place. That is important. We want to achieve excellent effluent water quality while achieving our process goal, minimizing energy use and using the plant equipment efficiently. Use the plant equipments efficiently. If the efficiency is 85%, if it is performing 30%, what happens? Only one equipment and it is not working. See that they are doing the performance rightly. Judge the effluent quality. Why? Why we are not getting the results? Is it a problem? Because it is coming up. What you will do? If the effluent quality is not that good, what you will do? You have the way. You will recirculate. Then you think, what is work? Just, oh no, we don't know. We just discharge and then create a problem and then start finding a solution. That is why these biological processes are very economic, but at the same time need a very skilled people to monitor. You have to monitor it correctly, right? So those are some of the important things you should do. Organic loading entering the active sludge is channeled into two directions: growth reaction and energy reaction, right? So some is used for the growth, some is for the, this energy used for different purposes. Organic nutrient biomass, new cells are produced by the growth reaction. Biomass is produced as a result of consumption of organic matter. If you will have to make sure whether that is happening. Okay? You have seen this, but our outlook is different here. Why we are doing? Oxidation of organic matter in wastewater is accomplished biologically using variety of microorganisms, primarily bacteria. Oxidation reaction produce energy for that. Correct. But we have a different ways of treating. It is not only yesterday you saw there was a concrete pond, you have put aerators and then you are treating. If there is a seasonal plant, if the volume is too high, 100 mld or 1000 mld, big plants, then you go for geomembrane. You can't do that. You do double liner geomembrane with the leak detection. You produce large wastewater at some time. I have some examples, case studies. You should have a space to store that and remove all suspended solids and then use it, right? So some days 24 hours working, large volume is produced for different ways of treating. So data must be organized for effective use. Put operating data in Excel spreadsheet and understand what it is, not the random numbers. You should sure of data why it is happening, why it is giving high, less, right? So you have to understand what is going on in the system. Then only you can diagnose the system and then only you can treat it, right? Sludge production versus SRT for activated sludge. See, solid production, solid retention time. You are changing the retention time. What is the solid settleability? How whether it is decreasing, whether it is happening. All that has to be analyzed. Oxygen requirement. So, solid settleability is the result, but this is the requirement for organic matters to have that. More process control data, flow rate, pH, microscopic analysis, solid concentration. We have already covered this in the earlier. Then influent flow, return sludge, we have kind of an understanding what it is. Then aeration tank effluent, this we have seen. I think it is repeated. Okay. Common operator errors, we have seen that a little bit, right? Automated DO controls, how the DO in the system is controlled. right? Then aeration system efficiency responds to influent BOD and TKN loading variation. What is TKN? Organic nitrogen, right? So a wastewater treatment plant may save considerable energy by quickly adjusting the variable conditions within the waste, right? Oxygen requirement for biotreatment is proportional to organic and TKN loading in the influent wastewater. You see, what are the parameters affect the treatment? First, you should have that understanding. If you don't know what are the factors affecting, if you do not know the philosophy, how we will do the variation, how we will make it more efficient, right? That should be done by numbers. They say that today it is this, it is happening, oxygen is required, organic compound is reduced. But what are the other parameters which can cause a hindrance, right? So that also you see inhibitors. Are there any inhibitors? When the system is working properly, but you have everything in place, but you are not getting the right efficiency, what you will do? Why we are not getting the right results? Why you are not achieving? Everything is what is designed is correct. We have right organic loading, hydraulic loading, everything is there, pH, but effluent quality is not coming. Why? What may be the reason? Then you will analyze, are there any inhibitors in the wastewater which is preventing, which you have not thought of before? It may be entering the system. Do analysis. You take a sample, do priority analysis, do other analysis and see somebody is discharging which we are not able to track. Why efficiency is reduced? So those are the things have to be analyzed and continuously on that. So that is only possible by doing analysis and having a proper training, proper design. Then if you don't understand what is happening, then you will evaluate the situation. That is why it is known as interference. One thing, if there is an interference, you will understand. There may be interference. If it is a passing through, still a problem. So that is, the perspective is different. How you do manage this? Oxygen demand for aeration drops in the middle, that you have seen already. Problems with not analyzing the data. Failures to carefully review process data may lead to bad process decisions. So if you don't know what is happening properly, this will cause another problem. First, you don't know what is happening. You start treating it in differently. Then you will understand that is not the real problem. So you have created another problem. Just like when you go to the doctors, if it is not diagnosed properly, you are not treating that, and you are giving some medicine which may cause problem. It is not there. That is what you do. You double check. Go to expert. Similarly here, you take some help of the experts there. We are doing all this, but still there is no. So that is how we improve the system. Sludge settleability problems may occur, effluent quality may deteriorate, operating cost may increase, violation may occur. Otherwise, what happens? You have to spend a lot of money on violations. You cannot violate every day. Then what happens? They will set down. They will ask you to set down. They will say you have to put a new treatment plan. You find out. See, we were talking about one example. If there was a TDS, we suddenly move to the other kind of a treatment. You cannot expect that activated sludge will remove TDS if it is a dissolved, because you are not measuring the TDS at the source, at the influent, because it is not there. It is not mentioned your authorization. See, that is not my fault. But effluent quality is no. But if there is nothing is measured, no measurement, no pollution. If a lot of blow down water is coming from the air conditions or different sources with a high TDS, if it is passing through, you should understand whether that is required to analyze. Why you are not put the limits. That is why you have an understanding the source of wastewater, to what industry it is, from the industry it is entering, right? So how you do? No need to keep remembering that. There are manuals. These industry, probably these are the parameters. First your thought is, let us see the menu. These industries produce following stuff. Correct? Then accordingly you create an authorization. You put more parameters. If that is not there, then you will see, you take a sample, you see other analysis you will do priority pollutant analysis, where we ask them to do about 100, more than 100 pollutants to be do a scan microscopic and find out. Then you will understand, oh, we haven't thought about this at all, but it is entering into the system. It may be entering in, professor was asking, if it is in a minute will just destroy the biological, because biological system is not immune to that kind of an pollutant. So then you will understand, oh, we have to put this. If it is a color, you will understand. If it is a TDS, you will not understand, because it doesn't have a color. You see, TDS, your water, groundwater looks as the surface water, clearly. But if you taste, it is different, right? Because iron and manganese, that change the taste. But TDS, it will cause another problem. So that is why you see, you will study hardness, which is not there in the system. You see how hard this water is, what is acceptable, what is not acceptable. If your source in the industry is groundwater, different problem. It has a TDS already. How much TDS? If you are not aware, we are using water. He said, what is the source of your water? Groundwater. Yesterday you had been there. What was the source? Groundwater. So we are taking groundwater, treating all that. But have you analyzed what is the TDS at the source? If you use the surface water, your results are different. If you use the groundwater, results are different. When you do that, industry itself, there are many industries which I monitor. TDS itself is high, 200, 300 at the source. What is the groundwater standard? 500. It becomes difficult. Source only you are giving a 300. If you put 100 there in the effluent, then you need a treatment before you use. So these are the things which help you to make a decision. Failure carefully review process data lead to the bad process decisions. You will make a wrong decision. You don't know they are using water, but system is not working, because high DDS you have never realized it. So that is why the perspective is different. What we are doing, we learned the system how it is working, then we started analyzing the data, then what we are doing, we are understanding the failures, what are the different reasons. So you should think in that manner, oh, there is a failure here. When you come to know which source you are using, TDS, that is, it is affecting the overall biological systems, so we have to go back. correct that, right? That is the way how you think. Operating cost may increase, then violations, we have seen that there may be a more spend. If you ask them to put a continuous fine, then they say, we will do that. It is better to do the system than putting the penalty. I have told you earlier, because for industries, if you ask them to pay certain fine and not doing, if they want to run without that for years or few months, they are still better. But your aim is to protect environment and water quality, not to collect money, right? That is one of the tool to prevent that. So that is what the very concept of putting the limits, standards, monitoring, right? So determine MLS concentration, optimization process performance. See whether biological MLVSS means the bacterial load exists or not. If the bacteria are not there in a sufficient concentration at a rate of 200, 2000 to 4000 in the aerobic treatment, and how we expect the water quality, effluent quality. See, perspective is changed now. When we were doing the other things, what parameters to be measured? Our perspective was to collect the data. Then now here, failures we are finding out. We are digging a little bit deep, right? So that is a very understanding. Reduce aeration, save energy. Right. This we have seen. Here is energy saving conventionally activated sludge. You can compare. Energy used for conventionally activated sludge is this much for BOD removal per MLD or per gallons or per liters, and how you will save this energy. You cannot just overuse the energy. Minimum, maximum is always there. This we have seen that some approximate values, particular example, approximately. Some percentage. In oxidation ditch, turn aerator off 4 to 6 hours per day will achieve energy saving 12%. How this number came? I did some study series of study. That is why if you need, we are going towards the saving of money, right? That is also important. We are also, which is our more focus? Quality. Then once quality is there, achieved, then we say how we can reduce the cost. Correct? In a building design, what you do first? You will do structural stability first. Then the cost saving. Then the architecture. Your structure should be stable. That is what the kind of an understanding you will go on reducing. Right? Once it is in, if there is a variation in a day itself, hourly variation, you can keep the aerator on. Once the oxygen level goes up, then you can set that off. Right? This aerator is a big consumption. That is why other biological processes are evolving to reduce this cost. You can imagine how much, if you have big pond, number of aerators, how much is the energy? Energy cost is enormous. So that is why it is important to see the economics once you achieve the quality. Okay, so this is the regarding how we achieve the quality, economics, save the money, energy is the very concept of this structure, because our approach is different. Earlier we were trying to understand the process, we are trying to make it efficient, we wanted to achieve a quality. Once you achieve the quality, then we go for savings. And also we have seen number of chemicals used in the system. How we can reduce the usage of the chemical, how you can store, what are the consequences. Is it possible to achieve economy in using the chemicals also? Sure, you have seen many examples, right? Once the quality is achieved, you think in a different direction. And we also analyze if everything is working fine, but still we do not have the results. What may be the concern? There may be a different concern which may not be knowing. So you will start analyzing. If you do not know, then you will hire a people who can understand data. If you have a data, then only you can see what is happening. That is why representative data is important. I am emphasizing more on, as we understand the process coming this side, various consequences and the importance of data, right? Once you know this is the data, then you can make a determination. There may be other thing, something may be happening in the influent which we are not monitoring, or some of the concentration contaminants are passing through, it is affecting our biologicals. So how you see it is affecting our biological system, then you see what is the MLSS and MLVSS values, whether bacteria exist or not, right? You are not, don't want to a system which will just pass through. You don't want to treat for the sake of treating. You don't want to treat for just to show that we are treating something. So then you will see why it is not happening. Then you want to also analyze for the quality what kind of bacteria are existing. You want to also analyze whether anything coming or going through the sludge which is causing a problem, right? If it is a contaminated sludge, where you want to dispose, you want to cause another problem. That is the very purpose. Then you also want to see if the efficiency is reducing, if there is a contaminant, where that contaminant is going. You see the influent is in the contaminant. Contaminant is in the influent and effluent it is not there. So where it is going? What you will do? You will see whether the bacterial, whether anything, that contaminant concentration exists in the sludge, because you remove, recycle 40 to 60% of the sludge. Then you will analyze whether that is just going, depositing in the sludge, and same you are transferring. So how different direction, how it is possible? If you give a lecture, because we have worked on the field, we know why it is failing. If you, I will say 40% should be recycled, see that this is achieving. Not you, if you are not able to do what you learned in the book, we are doing a far perfect. But in the field, what is happening exactly? Whether whatever you are learned is transferred, designed is on the site. That is very important. You should have an understanding how the things work on the field. If you are working on the field, you will understand. That combination is what is they are teaching is it different? No, that is correct. But that is a process. What is that? That is a general process. Influent comes here, grit is removed, suspended solids are removed, it goes to the aeration. Aeration, this organic compound is converted into stable compounds. Then we recirculate, then we give disinfection, and then this. Is it right? Is it wrong? No, this is right. But what is happening? You see yesterday how it is complemented. I mean, how complicated the system is. How we will transfer this skill to the field. That is the design. When you design and monitor, you will understand, you will go back. Otherwise, I'll say this is what I have learned. Both are not wrong. We want to see whether the system is working on the system, on the field. You will analyze the data and make the determination. It is easy to say that bacteria removes the organic compound. Whether is it removed? If you ask me, if you ask a researcher here, is it removed? How it is removed? How you say surely that it is removed? Do you have any data? If yours that sludge generated, is it free from the material? Do you have analysis? Did you see whether bacteria are really removed? If it is in the influent and it is not in the effluent, where it is going? That is what all has to be done there. You see, that is a transforming skill from design to the field, learning to the field, implementation. Then you see it is designed on the paper, so 95% efficiency. How much efficiency you are getting? Is it wrong? No, the design is correct, but it needs a little tweaking, analyzing, modifying the same. Surface water is discharged and then sewage enters the system and the system. This is true, equal, but you are not taken into consideration what is the source of water. If it has a TDS, your design is correct, looks correct, because very beginning only there is a failure. So these are the things you have to pay attention. You have to, when you work on the field and see, design, implement, monitor, is a very important job. So you have to analyze each components. You have to have a good team whether the things are working or not. See, why we know, we have seen things are not working, design is wrong. Oh, I've done the same design and I have monitored. There are things are different. We forget this one. Nothing wrong. You can implement, modify. You see how important is your document of authorization to a big industry, multi-million industry. When you are giving, they will say, whatever you have said, we have done. We are discharging it to the river. You said, yeah, we are discharging it to the river. This is the river. What is wrong? Nothing wrong. But there are so many changes, so many components you will have to. That was the very intent of this system. I want you to understand the system, how it is built in a different layer, made it consolidated, compact, concealed, right? What are the different components you should understand? Then you will be able to understand the system and implement. And it is really working. When it is really working, you will be happy. You have seen earlier, they said earlier it was bad, now we are improving. It is a focus. What is wrong? What went wrong? Nothing wrong. You can improve that. But first you should know what is wrong, where the error is, then you can do. So that is very much understanding about this course. You learned lot of things on that. Failures are the first step for the success. That is why if anything doesn't happen, it's not necessary to say that it is a failure. You will learn and make it more correct. You will become more smart. People who face more failures, they will become more smart. Right? That is how it is. So you need in a group of people combinations to make it more successful. Right? That is, so we have seen how data is analyzed in a different direction. We have seen the same purpose, some of the things earlier, but our perspective was different. And here our perspective changed. The way we look at the data we want to use, how we want to use it, why it happened. You started thinking, go deeper and deeper, right? So that is how we will have to do the things properly, and you can learning is always open. So that is how you become more efficient. Things will work, right? So this is what this lecture is. If you have any question, we'll talk.
Sir, you talked about doing things responsibly, and if you are failing, you try again and again. So, my question to you is very simple: how philosophy can save the environment in a better way? Can you please elaborate on that? How philosophical thoughts can save the environment, can improve the work culture?
Correct. First, your work culture, dedication, focus has to be there. You want to correct it if it is wrong. So, if you are a plant manager, you want to make sure, understand yourself how the plant is performed. You are already expert in certain area, but certain area is not possible. Then you will hire an expert there. You will give a proper training to the person. This is a very fundamental philosophy, right? And you will train them. You will see the design. This was the efficiency. This unit, what is the efficiency of this unit? You will do. You will have to lead the team. No? Otherwise, what happen? If the person who is in charge is not doing it rightly, which is what happening in the field, but other people it is, it's of no use. So that is why there may be a failures. You see, address, find the error. That is why this was more focused on where are the failures in the field. How you do on the paper, how you do on the field is slightly different. It is not totally different, but when you are implementing large volume is there. Are there any a situation where this was not understood, this was not given known in the beginning? If you know, the things will change. Some things you will have to correct it as you move forward. So that is what is my intent is it? That is why I gave an example. You said the influent, but there was no measurement of the TDS because you have not thought what is the source of your water. That's why your biological system is upset. If you know later TDS, what you will do? First, you treat the water, bring it to certain level which is not harmful to this biological treatment, and then you do. But if it is not done, it is designed by a person and this is not working. That's not the solution. You want to make it working. That is what yesterday in the visit they said earlier it was not working. The same group of people, same treatment, not. But now they said that it is working better. How? Because they focus, they want to improve that. That is what I mean. So they said, earlier they said, no, it was not working, we are having a lot of issues, but today it is working. But same group of people, same treatment plan, how they improve. That is the focus. Because they were working towards the success. They want to make it work. There may be still some errors, right? That is there. That is one part. Second part is They said we are doing the things what is given. That they are not wrong. Then where you find the error? People who have given the authorization, they have not done it. They could have put more effort in making it the document, understanding it. Legally, they are correct. What they have said, we are doing it. This here also you need a much smarter people, more dedicated people. We want to do it right. See, if it is wrong here, we will improve. We will modify the authorization. We will put this parameter. You can do, right? That is what I mean. You will have to. You need a consistent monitoring in a biological system. In the biological system, that is what I want to say, that my experience working for many years in the biological system point, that's right from designing to monitoring to reusing, it is, you need a proper attention. It is a laborious, it is a continuous working. If it is a chemical, you put a chemical treatment, you put a chemicals, this is treated and this is disposed. You need not to think much. You will go exactly like a book, it will happen. It is a chemical. If it is a circuit you design, if it is not working, it won't light up here. Oh, there is a problem. Correct. Right. But here you have to be more careful, because your one negligence may cause disruption to a lot of things. You are discharging it without treating to the river, and first the things are not done it properly. If you are aim to correct every stage and make it successful, then it will be. That is why they will feel proud today. We were doing not correct, but now we are doing it better. Then they will think further. If we are discharged, if they are really want to have the care for the environment, I have seen many industries stepped forward. It is not like that. They have said, no, we are using this treated. I will give you some examples. It is a one easier way. What happens is, you take the authorization, treat, this much is the cost, done. We are happy. But many people have gone further, make it to reuse that water. They have gone further step to reuse that water. There may be an economic element also, I agree. But many industries have done, they have made it use 100% reclamation. I gave you on the way one company, Microsoft there. So initially they were discharging it to the city. It was going for many years. Then they found, we will invest in the technology, make it green industry or something. Then they did a closed loop, no discharge, keep using that water. Then whenever it is inevitable, that time you discharge and keep using that water. That is possible. How that is possible? It may be in the beginning economically not viable, but now on the run is viable. But how this happened? You tell me.
Sir, in addition to training part, right? We are giving technical training actually. So in addition to that, if we give little bit of philosophical thinking also, it will help a lot. That is what I think actually, sir. So what do you think on this, sir?
No, I agree. But ultimately, things are done with people only, right?
Yes, sir.
See, they also have an intention. That is why, if you have an intent that I really want to contribute and make it successful, that your thinking line will change. You will work more hard, right? Doing just the, it is a different question, but I will put in this way: just doing the job and doing with the fashion is different. Some people will work after hours also. Why they do? Huh? Why they do? They need not to do it. But if they do, minimum is sufficient. You can talk more and work less. That is also possible. When this happens, some people take a extra work responsibility without anything. Why they do? Suppose you are there, you do their duty. If it is not working, no, that's not my job. I will give you a few more different examples which we practice. Many people have practiced like that. So that happens. It is not only in that. I'm telling you in the teaching also. Everywhere, wherever it is. Teaching also, some smart people, teachers identify, they spend more time, motivation they give, and they really give a big problems. Make it sure, that is how they become much smarter and they achieve. Some people may not be knowing the real potential. They may be wasting. Everybody has a talent, right? How you use is important, right? So those are some things I wanted to bring, that your focus should be do something right? That is what I yesterday I observed. The same group of people, they were telling it was not working, and now they say they are happy, they are working. And any suggestion we want to implement. See, they are asking any suggestions we want to implement. Means they are open. They want to go move in the right direction. But if you say, no, this was the regulation, no, we did. That is what I. Some teachers work after hours also. So they have that passion to have. They want to become more efficient themselves. Then only they can do. Right? If you don't know, you can always say, I do not know this, I will learn, and then again come and say. It is not necessary that you should know everything. Many situations happen like that. So that is, I wanted to say that you should have a lot of your focus is required. These are the processes where continuous monitoring is required. So that is why your focus is there. You have to need to more attention, learning, is it? Then contributing, learning, and again contributing. Everyday improvement to become. It is not a one-day job, right? So that is what my. Yes, go ahead.
So we visited four industries, see which plant we saw in 5 days. So in none of the industry we were able to see they were doing any heavy metal analysis. And then these heavy metal will be present in the biosolids, and they were even using these biosolids as a manure for growing plants. So these heavy metal would be in will be back to the land, and they will be go to the plants, or in water, when they will go to the fishes, and
Okay,
which will cause magnification and all.
great. Then who has to do that?
Sorry, sir?
Who has to do that? That metal analysis should be done. Who has to do that?
So
Who?
Actually, sir, they were using for heavy metals also
Uh,
activated charcoal. They were
Charcoal.
using
See,
exactly.
they were using.
They were using.
Okay. But your question, you just leave apart this one. Okay, they were using it. That time they may not be able to tell you because you did not ask that question. You are asking me here. When you were there, you did not know what did you do. I was expecting. They say that this we are using it for recycling, preparing all that. Did you ask? Did you analyze? What analysis you do on this? That is your part. Okay, I agree. But in certain places, certain situation, if they were not analyzing, then who has to tell them that you should analyze this? There is a possible. Who has to tell? You tell me. Who has to tell? Huh? Huh. See, they have to do always. If anything is coming out of that system and using in the environment, what is your first question?
Is it safe?
Is it contaminant free? How we will say it is contaminant free? You will say, did you do any analysis on it? Next step, what analysis you did? Next, what were the results? What are the standards? See, you go in that direction. When everything is said that we treat and apply it to the ground means we are first. That is what we are in the first few lectures I was mentioning about the use of biosolids
Yes.
as a manure.
Yes.
What was there? There is a big regulation. What to do, how to do, why it is required. I said in the beginning, if it consists of the metals, what you can do, where it will go? It will go to landfill.
Landfill.
Otherwise, if there are other methods also, they do, there are many methods where they can remove metals from the solids. They have to do that and dispose. That may be expensive,
Expensive.
right? But they have to do. They just cannot use the sludge which is or anything manure which has a contaminant. So that is why you see how many components we are looking at it. Asking question is very important. At first, people who are there in the system, they should ask question for themselves. Today, some researchers were asking me, want to do. So my first question to them is why you want to do. You are a researcher, no, you are heading towards big goal. Why you want to do? Why you want to do this only? How we will do is later. But you have to see whether this has been done already and you are not. I will see in the earlier visit, you said treated water we are using it for growing flowers. You saw that. If there are more technology, that is a good thing. At least they said the flowers are going with this. But we want to see is there any other people are doing like this. I will give you example I have given and I will give a few more. This water is used as an irrigation water to grow or irrigate millions of acres of land. It is already there. You are not seen because you think that this is what we are doing is. No, that is what the research is also. If it is already done, you don't know, you don't want to do it again. You want to find out where the things are not done and then you do. You spend so many years, oh, it is already done. That's why you do literature survey. What is done first? Try to understand what is not done. Where, if I say why you want to do, you say that then these are the things done. I see, I have searched these many things. There is a gap. You see, much work can be done. When anybody does the research, you will, at the end, you give this portion still may be carried out further. See, you are giving your base. So this is how I want to say that you should analyze, do the things correctly.
Thank you, sir.
Sir, actually, when we talk about India or some other developing countries, here the advanced processes or advanced technologies, just like the UV treatment and some membrane technologies or ultrafiltration, these are not much more feasible for the struggling industries, we can say. As they are saying they are discharging in the Gola River. Last day they told about that. So, sir, there should be, I think there should be more emphasis in the direction of the few alternates of the advanced technologies which are cost effective type of the technologies rather than we go for the advanced treatment, so that it can be treated in the more advanced way but in the cost effective way also.
Okay. Very good question.
Yes.
Please sit down. First thing is, you want to use most advanced technology, efficient. If you have an alternate available, you can use it. High cost. You want to use first, how we did? First we focused on water quality. Then we came to, when environment, water quality is safe, then we came to economics, right? That is how you do in the civil engineering also. First you check whether structurally stable or not. Then you see how economic you can do. Similar here. So it can be done. That is the very concept of common effluent treatment plant. Then if you are not able to do, unite 4-5 industry together. Take money, that is the collect the money, build a collection system. Is it? Have an ecology tank, bring all the wastewater there. We have an example also. That is why I said many cities have developed a big treatment plant only for industries. That is the same as the common effluent treatment plant. You can make it private. We have a group of people where, just like you build a big township uniting 4-5 corporations. Similarly, you build a industrial wastewater treatment, charge accordingly, and use the latest technology, make it more efficient. Use every product. When you treat, use it for growing the crop. Collect money from them. We have an example. That is what the delegation we give. What they do? There are cities also they do, and private group also. There are ports and other big industries. They can also accept others. It is privatization is also coming on that. Huh? Build, operate, and transfer, or group of people together. They build a big treatment plant and they accept wastewater. Based on that, the remuneration is collected, and you want to use a most efficient technology. For small industry, there are issues. That's what we learn. Small industry, they cannot build on their own. So that is why this is concept is to have a common effluent treatment plant. So they have a more resources to use a efficient, advanced technology at the same time save. That is more successful. That is also coming here. I think many places it is.
Thank you, sir.
Sir, as you have discussed in the previous lectures about the emerging contaminants, the PCBs and PFAs, and one of the most important emerging contaminants that we often read about is microplastics. Sir, so these pre-treatment and the secondary treatment are not that much effective for their treatment. So, are there any alternative methods by which we can treat those emerging contaminants?
Emerging contaminant in the sense plastic is the source.
Yes,
Please
sir.
sit down. Yes. Is the source, but you want to analyze and see what contaminant is there. If plastic is there, then you have a different kind of screen you can remove. But we want to see what is dissolved. If it is possible, if you can see openly, you can remove. But if it is dissolved, we want to find out what are the contaminants. Is it? Which is not seen by bare eyes. So that is our focus. Microplastic you can see in a water if you put it. If it is not seen, then you will analyze. What is the contaminant? It may be in addition to the contaminant, there may be many contaminants. Then you will identify, diagnose it, and properly identify the contaminant. Then you will treat them. Right? That is what you can. I will. That is what we said about one example, TDS, dissolved solids. You cannot see, you cannot even differentiate the two waters. But if it is there, then we find the treatment. We use the reverse osmosis. I gave you one case studies where they used uh, reverse osmosis. They didn't use the see which is necessarily required for that. It is not possible to treat conventional method. That is why that industry adopted pre-treatment, conventional, non-conventional, the reverse osmosis. They removed TDS to bring it to a certain level, and then they discharge it to the wastewater treatment plant. Then other stuffs are taken care of. So that is how it is done.
So this is the end of lecture 8. Thank you very much, sir, for this lecture, and we will assemble here for at 2:15, है ना? For 2 days, 2 दिन के लिए हम लोग का थोड़ा सा शेड्यूल टाइट रहेगा, तो आप exactly 2:15 में आ जाना. आज हम लोग का 5:30 तक लगभग चलेगा. We have only 2 days, and we have to complete rest of the lectures.